Hello dear students, welcome back to physics class. In today's class, let us explore the fascinating concept of motion that we see and experience in our daily life. But before starting with, I would like to tell you something important. Children, you have already studied kinematics in your class 7. So the same concept is repeated in your class 9 until concept number 7. So we have merged the videos of concept class 7 into the videos of class 9 until concept number 7. So please don't get confused and try to cope up with us. Okay? So now we begin with. So now moving to the worksheet number 5 of kinematics. Moving to the first question. An object undergoes an acceleration of 8 meter per second square. What is given, children? Acceleration was given as 8 meter per second square starting from rest. Starting from rest means initial velocity is 0. You find the distance travelled in 1 second. Time is given to be 1 second. You are asked to find the distance travelled. So before starting with the numericals, let us try to write the given data. So what is given data, children? First one, acceleration was given. How much acceleration they gave, children? Acceleration A is given to be 8 meter per second square. Okay, and starting from rest, what else was given, children? Starting from rest means initial velocity is taken as 0. You are asked to find the distance traveled in 1 second. So the time is also given to be 1 second. Time was given as 1 second and you are asked to find out the distance. So this is the given information. So children, we have studied the 3 equations of kinematics. What are the 3 equations of kinematics, children? One is V equals to U plus AT. Second one, S is equals to UT plus half AT square. And V square minus U square equals to 2AS. As you are asked to find the distance, so in this equation, there is no topic of distance. So there is no physical quantity of S is there. So we have to exclude this equation. So now in order to solve the numerical, either we have to go with this equation or the other. But here we have final velocity V is taken where the value of V is not given. Hence, in here V is not known, S is also not known. So, 2 unknown terms. So, we should not take this equation. The only possible equation to find out the distance S is UT plus half AT square, because you know the value of U, you know the value of T, you know the value of A as well as T square. Hence, depending on the formula, S is equals to UT plus half AT square. Here we start with them. So what is the formula you need to use, children? S is equals to UT plus half AT square. You are asked to find the value of S. What is U, children, here? U value was 0 because it starts from rest into how much time was given? Time was given as 1 second plus half acceleration. What was the acceleration given? 8 meter per second square. And the time is again 1. So 1 square is 1 into 1. So S is equals to UT plus half AT square. After further simplification, 2 goes 4 times. So 0 into anything is 0. So 0 plus this 4 into 1 into 4 into 1 into 1 is again 4. Hence, the distance was found to be 4 meters. What is the value, children? The distance is found to be 4 meters. Hence, the right option must be second option, 4 meters. Okay, children? So moving to the next question. So here, a racing car has a uniform acceleration of 4 meter per second square. So what is given, children? Acceleration was given to be 4 meter per second square. What distance will it cover in 10 seconds after the start? You are asked to find the distance and the time was given as 10 seconds, and after the start, the moment it starts means initial velocity is 0, similar to the previous problem. So first of all, let us try to write the given data. What is given data? Acceleration is given as 4 meter per second square. And distance you are asked to find out. Okay, what distance will it cover in? Time was given as 10 seconds. After the start means initial velocity u is equals to 0. So this is your given data. You're asked to find out distance. Again UTA. Based on this, what formula are we using, children? The only one and only formula, S is equals to ut plus half at square. Because if you go with the other two equation, there the final velocity is included, where we don't have any knowledge regarding the final velocity v. So only option to find the distance is ut plus half at square. So start with S is equals to, what is the rest, because the body starts from starting. At the moment it starts means the body starts from rest condition only. So here u is equals to 0. Time was given as how much? 10 seconds. So 0 into 10 plus half. What is the acceleration? 4 meter per second square. And again time was here 10 seconds. T square means 10 into 10. So after substitution, let us try to simplify. 2 goes by 2 times. S is equals to 0 into 10 is 0 plus 1 into 2 is 2, 2 into 10 is 20, 20 into 10 is 200. So S is equals to 0 plus 200, or S is equals to 200 meters. So here goes your answer, option number 3. S equals to ut plus half at square. U is 0, the first term goes off, and second term half into acceleration was 4 meter per second square into 10 into 10. For the simplification, you will be getting the answer as 200 meters. Moving to the next question. Yes. A train starts from rest, attains a velocity of 72 km per hour. Children, what is given here? 72 km per hour is given. And time was given as 5 minutes. Assume that the acceleration is uniform. You're asked to find the acceleration as well as the distance traveled by the train while it attained the velocity. So you're asked to find out two answers. First one you have to find the acceleration. The second one you have to find the distance traveled. Two questions were asked. But children, if you consider here, initially the acceleration they have asked, and this acceleration they gave it as meter per second square. But here in the question it was given in kilometer per hour is velocity. So you have to convert that kilometer per hour into meter per second to get in this format, SI unit. So before starting with, let us try to write the given data. What is given data, children? Velocity was given to be 72 kilometer per hour. So after simplification, we can write 72 into 1 kilometer per hour is equals to 5 by 18 meter per second. Okay, if you don't remember, let us try to write. Kilometer is nothing but 1000 meter. Hour is nothing but 3600 seconds. These two zeros gets cancelled. 2 goes 5 times and 2 goes 18 times. So 5 by 18 meter per second. So to convert kilometer per hour into meter per second, you need to multiply with 5 by 18 to get in meter per second. And this 18 goes how many times, children? 4 times. 18 4s 72. Okay, so 5 4s is 4 into 5 is 20 meter per second. So velocity was given to be 20 meter per second, and starting from rest means initial velocity is given as 0. So first case, starting from rest, initial velocity given as 0. Second case, attains a velocity, reaches a velocity of 72 kilometer per hour. That means final velocity is 72 kilometer per hour. Converting into meter per second, you got it as 20 meter per second. Two things. And what else is given? In how much time? In 5 minutes. Case 3. This is first one, this is second one, and third one, time was given as 5 minutes. But here the options are in meter per second square. So you need to convert time in seconds. That is 5 minutes into, each minute is 60 seconds. 5 into 60. So T is equals to 300 seconds. Okay, so U value is known, V value is known, T value is also known. Assuming the acceleration is uniform, find the acceleration. So to find out the value of acceleration, what formula you are using, children? You need to check out a formula where it includes V, U and T. to find the acceleration. So the first kinematic equation you are taking, V is equals to U plus AT, because you know the value of V, you also know the value of U, you also know the value of T. Only unknown is A. So you can find the value of A. So bring this U other side, children. What happens? V minus U by T. Okay, for your clarity, let me write it like this. V minus U is equals to AT. To find out the value of A, V minus U by T. Okay, children. So what is the formula for acceleration? A is equals to V minus U by T. So simplify. So after simplification, how much you are getting? A is equals to, what is V? 20. V is 20 minus U. What is the value of U? 0 upon, what is the value of time, children? 300. Isn't it? So A is everything in terms of meters, seconds only. Okay, distance everywhere. Distance is taken in meter, time is taken in seconds. So meter per seconds. So 20 by 300 is how much? 20 by 300 is nothing but 0, 0 gets cancelled. 2 goes 15 times. Hence A is equals to 1 by 15 meter per second square. So what is the value of acceleration, children? 1 by 15 meter per second square. So maybe the second option or the third option. You need to check it out. So in order to check it out whether which option is true, second or third, let us also try to solve the second numerical. What is the next part of the question? It was asked the distance traveled by the train while it attained the velocity. So what is the formula to find out the distance traveled, children? S is equals to UT plus half AT square. Either you can take this formula or you can even take the formula V square minus U square equals to 2AS. You can take either of the formula to get the answer, because you know the value of U 0, you know the value of T as 300 seconds, half, acceleration just now calculated as 1 by 15, time is again 300. So this you can use. Even this also, final velocity was 20 meter per second square, 0 to acceleration is 1 by 15 and distance you have to find out. So either of the equation you can use. So it's up to you. So children, as I have written the first one, I will be using this first equation. Okay. Well, so to find the value of S is nothing but 0, initial velocity is 0, time is taken as 300 seconds plus half, acceleration was 1 by 15, just now we have calculated, time is again T square, 300 into 300. So children, 2 goes 150 times and 15 goes 10 times. So 0 into anything is 0, hence the S value is 0 plus, here 10 into 300 is nothing but 3000, and here everything we considered in meters and seconds only. So distance you got it as in 3000 meters. How much is the distance you got? 3000 meters. But here options are given in kilometers. Children, 1 kilometer equals to 1000 meters. So 3000 meters must be equals to 3 kilometers. So this is also equals to 3 kilometers. Hence we found the acceleration as 1 by 15 meter per second square. And distance was found to be 3 kilometer per 3 kilometer. Hence 1 by 15 and 3. Here goes your answer. So answer will be second option. 1 by 15 meter per second square and 3 kilometers. So hope you understood. Okay, moving ahead with the next question. So here goes the fourth question, children. An object having a velocity of 4 meter per second. How much velocity was given? 4 meter per second. Is accelerated at the rate of 1.2 meter per second square for 5 seconds. You are asked to find the distance traveled during this period of acceleration. So first of all, we shall write down the given data. What is given data? So velocity is given by having a velocity. So initially it has some velocity 4 meter per second. Accelerated means velocity is being increased at the rate of accelerated at the rate of how much? Acceleration was given as 1.2 meter per second square during the time 5 seconds. You are asked to find the distance traveled during the period. So only initial velocity was given and no knowledge regarding the final velocity. So to find the distance traveled, first of all, let us try to write the given data. Initial velocity was given as 4 meter per second. 4.0 is nothing but 4 meter per second. And acceleration was found to be 1.2 meter per second square. Well, and time was given to be 5 seconds. You are asked to find the distance traveled. That's it. So you know the value of U, A and T, no knowledge regarding the V. So what formula are you using to find the value of S? Yes, the option will be, we have the only formula, S is equals to UT plus half AT squared. So what is U? Here 4 meters per second into time was 5 seconds plus half, acceleration was 1.2 meter per second square and time is again 5. T square means 5 into 5. Okay children? So this 2 goes 0.6 times because it is 1.2. So 2 into 0.6 is 1.2. Hence the value of S was found to be 4 5s is 20 plus here 6 5s are 30. So 0.6 into 5 is 3. Okay. And 3 into 5 is again 15. So the value of S is 20 plus 15 is 35 meters. So here goes your answer. First option, that is 35 meters. Okay children. So moving to the next question. A bus starts to move with an acceleration of 1 meter per second square. So what is the given data children? Acceleration was given as 1 meter per second square. A man who is 48 meters behind the bus runs with constant velocity of 10 meter per second to catch it. In how much time he will catch the bus? So initially the question itself is a bit confusing, but solution is no way difficult. So first of all, let us try to understand the given question with the help of a small number line. Okay. So what was given means a bus starts to move with an acceleration of 1 meter per second square. A man who is 48 meters behind the bus. So let us suppose the bus is here and 48 meters behind the bus means here the man stays. A bus starts to move with an acceleration. The acceleration of the bus was given as how much children? 1 meter per second square. Later we shall discuss values and all. I'll take later. Some acceleration was given behind the bus with constant velocity. Okay, a bus starts to move with an acceleration of 1 meter per second square. A man who is 48 meters behind the bus runs with constant velocity, no acceleration. Initial velocity, final velocity, everything remains the same. Okay, and how much velocity they gave it as? 10 meter per second to catch it. How much time he will catch the bus? Children, one thing you must know that, so the man moving, but the bus also starts from rest, is accelerator, bus also moving. In this case, both the bus and man are in motion. But the thing is, man moves with constant velocity, no acceleration, but the bus moves with acceleration. So whenever an object moves with constant velocity, the normal formula you'll be using is speed equals to distance by time. Speed equals to distance by time. This thing. Distance is equals to speed into time, because no change in velocity, constant velocity. Whenever constant velocity, simply S is equals to Vt. So school level, the basic level formula you'll be using. But here, when the bus is accelerating, in that case, the distance traveled, you have to use the formula as ut plus half at square. Because the bus is accelerating, you must rely on this formula. Whereas the man moves with constant velocity, you need to go with this formula. So make it clear, children. So now let us begin with the solution. And before and given data, so no need to write what is S, what is V, no need to write because I have already indicated every value here. So let us directly try to solve the numerical. So this is your finishing point where the bus also reaches here, the moment the man also reaches here, and the man gets into the bus. Okay, so the bus may travel from here to here, whereas the man may travel from here to here. So it's very clear that the man will cover a distance of this much from here, this point to this point, whereas the bus covers only this part of the distance. Okay, children. So what we discuss here is we can conclude that the distance traveled by the man, from here to here, yes or no? Distance traveled by the man can be written as here to here. What is this length? 48 meters. The distance traveled from here to here is this distance plus this distance. Okay, so this distance I considered is 48 and this distance is nothing but the distance traveled by the bus, because the bus travels only this part. Distance traveled by the bus plus distance 48 equals to distance traveled by the man. Is that clear, children? Okay, now we shall continue. So what I have written is the distance traveled by the man equals to 48 meters plus the distance traveled by the bus, because the bus he reaches here, the man also reaches here, and hence he will board inside the bus. What is the formula for distance traveled by the man? Well, now simply because he moves with constant velocity, V into T equals to 48 plus what is the distance traveled by the bus? Because it is accelerating, velocity is changing. So formula you need to consider as ut plus half at square. That's it, children. Okay, so let us now try to substitute. What is the value of V given? 10 meter per second. How much time? That only you need to find out. T. 48 plus what is the initial velocity of the bus? The bus starts means initial velocity is 0. So initial velocity of the bus is 0 into time plus half. Acceleration of the bus how much? 1. How much time? Unknown, that is t square. Okay, children. So I hope this formula is clear. Distance traveled by the man equals to from here to here 48 and from here to here distance traveled by the bus. Up to this it is clear. Distance traveled by the man is simply V into T. This is 48. Distance traveled by the bus is ut plus half at square. And with what velocity the man is moving with? 10 meter per second. So V is taken. Time you need to find out how much time equals to 48 plus initially the bus starts means initial velocity 0, time you need to find out plus half. Acceleration of the bus is given as 1 meter per second square and time you need to find out. So 10 into t can be written as 10t equals to 48 plus 0 into anything is 0. So this is 0 plus half t square. Okay, children. So taking the LCM and simplifying it, so how much are you getting it? So 0 just ignore, multiply throughout with t, 20t equals to this is 96 plus t square. What is that, children? 20t is equals to 96 plus t square. So further simplification, and how much are we getting? t square, bring this 20t other side, minus 20t plus 96 equals to 0. What is that? T square minus 20t plus 96 equals to 0. So, please cope up with me, children. The space is not sufficient. So, I would like to continue here. Okay, I hope this might not be confusing to you. So t square minus 20t plus 96 is equals to 0, and this is a quadratic equation. I hope you have already studied the solving quadratic equation in your mathematics, so that may help you out. So simplifying, first of all, take the factors of 20. 20 can be written as not 20, actually 96 factors. 96 can be written as 12 into 8, children. Okay, so 12 into 8 is 96. If you add 12 and 8, you will be getting 20. So 12 and 8. So you can write it as t square minus 12 minus 8. This is t plus 96 equals to 0. See, I hope the same equation, because t square matches. Minus 12t minus 8t is minus 20t plus 96, isn't it? So I have just rearranged it. Instead of minus 20t, I wrote it as minus 12t minus 8t. So in these two, if you take out common t, what you are left with? T minus 12. That's all. And here, if you consider minus 8 as common, then you are left with t minus, again 8 goes 12 times, equals to 0. So t minus 8 into, because take out t minus 12 common, you are left with t minus 8 into t minus 12 equals to 0. Hence we found the value of t as either as 8 seconds or t as found to be 12 seconds. So at what time the man is able to catch the bus? Maybe after 8 seconds or maybe after 12 seconds. Children, coming to the point. So, simple logic, if he could able to catch the bus in 8 seconds, does he wait for until 12 seconds? Let me again catch it at 12. No. So, always if you get two options for time, then always take the lesser value. And suppose if you get time instead of 8 and 12, if you get it as minus values, never, time is will be never be negative values. So never take negative values of time, and whatever will be the lesser term, you have to consider that only. So the time, how much time he takes to catch the bus, children? 8 seconds. So here goes your answer, 8 seconds. Okay.